Hi, the name of this Blender video tutorial is Relationship Constraints, Floor Constraint, and FollowPath Constraint. Two of the relationship constraints in Blender are the floor and FollowPath constraints. To demonstrate these constraints, I've modeled a simple sled object in my Blender scene named Sled, along with a flat plane object named Ground. One problem modelers sometimes face is placing an object directly on a ground plane. The floor constraint constrains an object so that it cannot cross in the selected X, Y, or Z axis the origin point of another object. I'll select the sled object and go to the constraint editor and add a floor constraint. In the target box, I'll select the ground plane object. By default, the origin point of the sled object cannot pass through the origin point of the ground object along the Z-axis. If I select the sled object and move it down the Z-axis, I cannot move it any further than the origin point of the plane object. The origin point for my sled object is located at the center of the geometry, and thus the sled sinks a bit into the ground plane. I will zoom in a bit on the sled object and go to wireframe view and then tab into edit mode. I've modeled the sled to have a small cylinder extending from the center of the sled down towards the bottom, even with the bottom of the sled skis. I will select this single bottom vertex. I'll then press Shift S and snap my 3D cursor to this selected vertex location. I'll then tab out of edit mode and click on the Origin button in the left tool panel. And I'll select Origin to 3D Cursor. This places the sled's origin point to the very bottom vertex of the center cylinder. I can now lower my sled object down along the Z-axis, and the sled will rest exactly on the top of the plane object. If I press the G key and grab the sled object, I can move it anywhere, maintaining its contact with the ground plane surface. I will remove the floor constraint by clicking on the X in the floor constraint panel. I'll then hide the layer that contains this ground plane, and then hide a new layer that contains a ground plane that has a wave-like hill. The name of this ground plane is Wave. I will select the sled and add a floor constraint. In the target box, I'll select the wave object. Now if I lower the sled along the Z-axis, it works very well on the flat portion of the wave ground plane. However, if I grab the sled and move it toward the wave portion, it does not stick to the surface because the wave origin point is here well below the surface top. To make the sled follow the wave plane surface, I'll use a different relationship constraint called FollowPath. I'll first select the plane object, then go to wireframe, and then tab into edit mode. I'll hold down my Alt key and select a single vertex. This selects the entire loop of vertices. I'll then press Shift D, then right-click, which will make a duplicate set of the vertices located in the exact position as the selected vertices. With the new set of vertices still selected, I'll press the P key and separate the new row of vertices from the wave plane object. Note in the outliner panel, I now have a new object called Wave.001. I'll rename this new object Sled Path. In order to use a path with a FollowPath constraint, the path must be a curve object. Currently, my sled path object is a mesh object. I'll select the sled path object and press Alt-C and convert the mesh object to a curve object. The sled path object is now a curve object. I'll then select the sled object, delete the floor constraint, and add a FollowPath constraint. In the target box, I'll select the sled path curve object, and I will checkmark Follow Curve. In doing this, the sled object has shot off to the side. To place the sled object at the start of the sled path object, I need to clear its location settings. To do this, I select the sled object and press Alt-G. This places the sled object at the start of the sled curve object. The FollowPath X, Y, and Z settings are all correct. I want the positive Y-axis of the sled to point forward and the positive Z-axis of the sled to point upward. I'll select the sled curve object and tab into Edit Mode. Notice that the path directional arrows indicate that the start of the path is on the left and the end is on the right. I can change this by clicking on the Switch Direction button in the Curves tool panel on the left. The start of the path is back on the left, and the sled is positioned on the left at the start of the path. I'll tab out of Edit Mode, and with the sled path still selected, go to the Object Data Editor. In the Path Animation panel, I need to make sure that the Path Animation box is checkmarked. The Frames controller sets the length of the animation over the length of the path. Since I want the animation to start at frame 1 and run the full 100 frames, this should be set to 100. The Evaluation Timer control is where I will add a keyframe animation. I'll make sure that I am in frame number 1, and make sure that the Evaluation Time control is set to 0. Right-click the Evaluation Time controller and add a keyframe at frame number 1. I'll then go to frame 100. Set the Evaluation Time control to 100, which moves the sled along the full length of the path. Then right-click the Evaluation Time control and add a keyframe for frame 100. I'll then go back to frame number 1 and play the animation. The sled object flows along the surface of the wave plane object, following the sled path.